Hi everybody, I'm Chris Seeley.
And I'm Nicholas Chen.
We're developer programs engineers on DoubleClick for Publishers Developer Relations, and today we're going to be talking about measuring creative performance. So when we say creative performance, we don't mean your click-through rate or your revenue. We're actually talking about your page speed performance. So modern websites have a lot more than just content, right? You have analytics, social media buttons, comments, and of course ads. So all of this stuff is really useful and adds a lot of value to your site, but it doesn't necessarily come for free. When you're loading all of this, it does take time, and you want to make sure that you're not hurting the user experience. So how can you make sure that the ads you're loading on your site aren't taking forever and hurting the user experience? Because as it turns out, if you're the average site, there's a good chance they are. Ad blocking leads to a 2x improvement in load times. This is the big finding from a couple of big names, including the New York Times. They did a study where they installed a mobile ad blocker, and they found that half of the data that was being retrieved by the phone was coming from ads. So if you think about how long it takes to load data on a 3G connection, and the fact that some users may have data caps and actually be paying extra money to load ads, is a pretty big deal. And the IAB really hit the nail on the head here when they're talking about short-term versus long-term gains and making sure that protecting the user experience, you don't prioritize the short-term gains and drive users to thinking about ad blockers. One more from PubNation, 4.1 seconds. This is on a desktop device. They installed an ad blocker and found that it loaded 113% faster, more than twice as fast when they blocked ads. So it's a pretty big deal. How can you actually make sure that you're not hurting user experience in this way? And how can the DFP API help you do it? And that's what we're going to talk about. First, we'll cover how to measure performance in a one-off case, what tools and techniques you can use. Then we'll talk about integrating with your existing testing workflow. How can you bring that one-off case into a repeatable, automated, programmatic way? And finally, where does a DFP API come in? How can you build this end-to-end workflow and validate every creative that comes into your network? So some of you may be familiar with this screen. It's a screenshot of the Chrome Developer Console, and it's a really useful tool for debugging one-off cases. And I just want to call out some specific properties it has for debugging performance issues. And the first I want to call out is this window performance object. This is the JavaScript console. So you can open up the JavaScript console and check out this performance object. And what Chrome does is when it loads a page, it captures all this performance and timing statistics, every page load event, DOM content ready event, all that great data, all the network events. It captures all of that. So you can look at how long it took to load individual images, how long it took to load an iframe, things along those lines. So you can see actually how long your individual creative took to load. There's also network throttling. So if you want to simulate a 3G connection, you can do that. You just click over here and it'll simulate both the latency and the bandwidth for you. And finally, if you want to emulate a certain device, if you have ads that are targeted to iOS or Android and you want to make sure that those are served when you're testing, you can emulate a Nexus 5 or some other device. And keep in mind that this does not emulate GPU and CPU. This is just your user agent to get the appropriate ads. That's great for investigating the one-off case and looking at individual ads and creatives and seeing how they impact your site. But how can you make this larger scale? How can you make this integrated with your testing workflow and validate all your creatives? To do that, we looked at Selenium WebDriver. So it's an automation testing tool, and it controls browsers. A lot of you are probably familiar with it, and end-to-end tests, unit tests, automation testing. And basically, you write an application in a language that Selenium has a library in, like Java or Python, and that application will send commands to a browser through some executable. In this case, we used a Chrome driver executable, which launches a Chrome instance. So all your commands, it'll load up your site, run whatever JavaScript you want, whatever commands you want to, and it'll send those to the browser, and that will be sent back to the application. So wouldn't it be great if you could get all of this data from the performance timing object in your application and you could access that programmatically? Well, it turns out we're not the first ones to think of this. And in 2013 at the Google Testing and Automation Conference, GTAC, Michael Klepikov, hopefully I'm pronouncing that correctly, introduced this extension for Chrome driver for the performance log. And what this does is it takes that performance timing and just creates a new log type. And it passes all the information back to your Chrome driver application as logs. So this is an example Java code to get this going, and you can just see it's a new log type for performance. And you just add this to your WebDriver application, and this will tell Chrome, hey, I want those performance statistics, give those to me in the type of a log. So what does it look like when you actually run your application? It spits out a bunch of logging. And I've actually cut this down a lot, but there's a huge amount of information here, and you can get all the same exact details that you got in a one-off case when you're debugging in the form of logs. And you can see here that I'm going to call out DOM content event fired and page load event fired. And we get awesome timestamps here, really useful. So if you don't remember offhand what DOM content event fired and load event fired are, I have a convenient definition. So it's fired when the HTML document has been loaded, but it doesn't wait for CSS or images or your subframes to finish loading. The load event fires when the page has fully loaded. So what Nick and I found was, in the case of DFP at least, all your ads are in iframes. So the first event fires before your iframes have finished loading, and the second event fires after they've finished loading. So if you do a difference between the two, it was actually a reasonable estimate on simple pages for the load time for those creatives. So you see we took the diff here, and these are in seconds, and it was about half a second in this example case to load the ad. Again, this is just a high-level first pass at this. If you have a simple page, this worked out well for us on our simple test page, but if you do have a more detailed page and you want to run this on a page that has tons of iframes, tons of different creatives on it at one time, you'll want to, again, go back to that first step where you're looking at the one-off case, figure out exactly what metrics you want to use and what makes sense for you, and then find those within the logs. There's a ton of log data. It's all available there. You just got to sort of sift through it and then recreate what you were doing in the one-off case. What about the other stuff? How about emulating devices? That's also possible. This is just example code. There's resources at the end that you can use that sets this all up for you, but it's just to show you that you can emulate a device like an Nexus 5 and pass that along, and you'll notice when you run your application, Chrome will actually start up and in the emulation mode, and it'll adjust the screen size and request ads appropriately. Throttling network connections. To achieve this, Nick and I actually used a proxy. There was no way to set this up programmatically in the WebDriver, but you can easily do it through a proxy, and we had really great results doing this. And the developer console does have example presets, so when you select 3G, it'll say what the bandwidth is and what the latency is and round trip time, things like that to help you get started with your settings. So now that we know how to do this in the one-off case and programmatically, we're going to talk about where the DFP API comes in, and that's where Nick comes in.
Cool. So now that we're all self-proclaimed experts with Selenium Testing Suite and Chrome WebDriver, you're probably asking yourself, what does this have to do with the DFP API? After all, this is a DFP API talk, so we should probably tie it all together. So one of my favorite services, and very, very underrated in my opinion, is the line item creative association service. Aside from being a mouthful, it's something that almost every developer has used, since you need to create a line item creative association in order to get a actually serving line item. One of the lesser used methods within this service is actually the get preview URL method, also one of my favorites. Using this will actually generate a Google hosted temporary URL that renders the creative in question along with the content of the site URL provided. What does this mean to you? Well, this is equivalent to going into the Creative tab in Trafficking and clicking on Generate Insight Preview URL. It lets you see what your creative looks like on your actual live page. This is great, especially in the case of custom creatives and third-party creatives, as it lets you see any code interactions that might be taking place that you're not fully aware of. But before we get to that, there's a few prerequisites that you need to accomplish before you can generate this preview URL. One, you need a test page URL with properly targeted DFP tags. This means GPT tags that actually point at a line item that you want to serve to that page. Keep in mind, this line item doesn't have to be live, it doesn't have to be active, it doesn't have to serve, but it does have to be properly targeted to your page. Second, you need a line item creative association. Without telling it what line item and what creative you want to serve, we can't really generate a test page for you. So make one of these. Again, the benefit here is that you can see how custom creative code interacts with a live serving page. Maybe your test page has a lot of JS in the header. You might have a third-party creative that's sent over by the advertiser that also has a lot of JS code. Sometimes it works, sometimes it doesn't. Using a preview URL in this manner will let you see if it does. The next part of the challenge is to identify what creatives you care about, the creatives that you want to test. But before we get to that, and I don't want to sound like a broken record, as I probably do to a lot of you, you should be using last modified date time. This is available on almost every one of our services. You can check our developer docs to see if it is, and it's a best practice for syncing down data. There's no point in pulling down a full data set if you only need to pick up the ones that have recently been changed. So in order to scan or filter for creatives in your network, you have a few options to do this. Maybe you have a particular skill set, a skill set that you've developed over many sprint cycles, a skill set that makes you a nightmare for advertisers who send you poorly performing creatives. I don't know what you plan on doing, but if you filter by advertiser, you might be able to identify and work out your technical differences with them. You could also filter by type. It might be the case that only certain types of creatives are poorly performing. Maybe your Flash creatives are taking longer to load. Maybe it's your video creatives. Maybe it's your large, unoptimized for web PNG creatives. But you can filter by type and get a high-level overview of what types of creatives are poorly performing in your network. You could also filter by size. This is a de facto method for filtering by the environment in which your creatives are serving. There are certain ad slot sizes that only serve to video, and some that only serve to mobile. By doing this, you can see on what platform they're poorly performing. Additionally, if you're going by the traditional display ad slot sizes, you might notice that your 728 by 90 is slow loading. This is the first banner that your user sees when visiting the page. If you can identify this, you can do something about it. So putting it all together, how does everything fit together from the API? Well, first, because Chris and I had no network to start with, we started with an empty test network and we created a dummy line item. As I mentioned before, your line item doesn't actually have to serve, but you do need a line item to generate a line item creative association with. Secondly, you need a test page. Maybe you already have a production page on which your tags don't change that often, in which case you're done. In our case, we didn't have a website, so we made an empty page that had properly targeted GPT tagging on it. The third point, you have to find new creatives. In our case, we didn't want to filter by advertiser, we just wanted to find all creatives that were added to our network. Once you find these creatives, make sure to add the sizes to the line item creative placeholders so the targeting is correct. Otherwise, your Leica won't serve and you can't preview the creative. Lastly, you need to create the Leica. Without creating the Leica, you can't generate the preview URL. So, last step. So this entire time we've been talking about creative optimization, getting faster performing creatives, but there's other possibilities along with Selenium and the DFP API. You might have seen your traffickers or your UX team actually go into the UI and click on that Generate Insight Preview URL before. This is great because it lets you see how creatives look on a page. This is not so great because it doesn't really scale when you're talking about hundreds or thousands of creatives. If you tie together Selenium WebDriver with the DFP API, you can generate tons of screenshots at scale, and you can send them to your UX team, you can send them to your traffickers, and they can see how many creatives actually look on live serving test pages. You can validate click-through URLs. This is actually a real concern that was brought up to us by a publisher. They were concerned because of the behavior of third-party or custom creatives in that you can override click-through URLs via custom code that they weren't clicking through to what the advertiser was saying. You can set up a Selenium check to actually click on the creative itself and see where it takes you to make sure that nothing's being overridden. Lastly, you want to ensure cross-browser compatibility. This is becoming more of a concern with more and more browsers arising and with HTML5 creatives. Since Selenium WebDriver actually has binaries for Firefox, Opera, Safari, Chrome, every major browser, you can test to see what your creatives look like in each one, making sure that you don't get a blank box in, say, Safari. So because Chris and I like to actually code, we don't want to lie to you, and we want to prove to you that this is more than a proof of concept. Don't worry, that URL will be available in our slide deck. We put together a demo app. So this demo app is a composite of our test network with various creatives in it, as well as running through their creative performance in WebDriver and loading it in a variety of environments. The top table is actually the creative performance in a Chrome mobile high environment, so that's a 3G connection. And I want to call out the left axis, the y-axis, is loaded in time in seconds. I want to call out this particular creative. I drew a threshold line of 8 seconds because that is an arbitrary point that I feel like is acceptable for me for an ad to load on a mobile browser. You'll notice that this ad took 22 seconds to load. If I were visiting this page or this app and saw that a creative was taking 22 seconds to load, I would have left 2.5 times over. So this might be a case in which you identified a creative that's not optimized for mobile web. If we scroll down and look at the same creative, this is in an environment for desktop, Chrome, high. So that's a broadband connection, and you'll notice that the y-axis is now shifted from 1 to 2 seconds. The scale is literally an order of magnitude less. I've also marked acceptable web performance as 1 second, because on a desktop I would expect ads to load a lot faster. While this same particular ad still took 1.7 seconds to load, which is beyond my threshold, it's still a lot faster than I would have expected. This might be a case in which the advertiser has sent you a creative that's optimized for web, but not for mobile. Of course, if you had something like this, you can go back and identify the advertiser in question and hopefully have them send you a mobile optimized creative. So to bring this all together again, what did we talk about today? You have to have a network with line items and creatives. We didn't, so we created a test network, we added a line item that targets everything, and we tested our creatives. You need to find and create line item creative associations. Since ours was a brand new network, we filtered on last modified date time to pick up on newly created creatives, and we generated line item creative associations from those. From those line item creative associations, we generated preview URLs for all of them. And then we loaded each URL that we got back into the WebDriver application that Chris wrote. And we recorded our performance statistics. Our app is built on App Engine, so we used NDB as a backing database. You might be using MySQL, NoSQL, whatever you're using, just store it somewhere. In the end, you get a better publisher experience, you get more ads that are actually viewed without people leaving the page, and you also get a better user experience. Users aren't seeing those blank white boxes because your content has loaded so much faster than a poorly performing ad. Also, they're more likely to click on ads that are relevant to them and they see firsthand. All in all, I feel like we've demonstrated that if you can combine Selenium WebDriver with the DFP API, you get a perfect match.